Hi, this is Francis from A+ Tutoring. In this session, I'm going to show you how to evaluate this question, which is in the past final exam 1, number 2b. Evaluate this following limit. First thing that you have to check is plug in x as infinity. And you get 0 for this term, 0 for this term, and I have 1 to the power of infinity. And this is basically one of the indeterminate form for L'Hopital's rule. But however, I cannot apply L'Hopital's rule because it's something like this. I have to transform it into 0 over 0 or infinity over infinity. Otherwise, I cannot use L'Hopital's rule, right? So now, how can I transform that? If I have something to the exponent x, the trick that I'm going to show you, it applies, I would say, 90% of the time. You write y equals to this limit first, then apply ln. 1 plus 2 over x plus 1 over x squared to the x. Then you apply ln, so it becomes ln of y equals to limit of x approaching to infinity, ln of this function here to the power of x. Now you can bring down the x because it's the exponent is one of the properties for ln, right? So you have ln of y equals to limit of x approaching to infinity, x ln of 1 plus 2 over x plus 1 over x squared. Now you have something like this that you have to check again. With x approaching to infinity, you have infinity times this part is 0, 0, so ln of 1, which is 0. So basically, I have infinity times 0. If you look at the indeterminate form again, this is basically one of the things that we're not sure is 0 times infinity, right? So I have to transform it again to make it 0 over 0 or infinity over infinity. Now, how do we do this? This is one of the other trick here. If you have terms like this, you have to make one of the part to the bottom and make it into a fraction. So what am I saying is ln of y equals to limit of x approaching to infinity, ln of 1 plus 2 over x plus 1 over x squared over 1 over x. So you have something like this. Okay. This is going to be 0 over 0. So that you know this, we can apply L'Hopital's rule. Now, let me do that on the next page. If I rewrite the answer here, limit of x approaching to infinity, ln of 1 plus 1, 2 over x. Sorry. So let me erase that here. 2 over x plus 1 over x squared over 1 over x. Now, if you look at the top part here, 2 over x is basically 2x minus 1. 1 over x squared is basically x to the power of minus 2. And 1 over x is basically x to the power minus 1, right? So I can apply my derivative now, because if I write this like this, it will be easier to evaluate the derivative. So I'm not going to write ln of y anymore. I'm just going to apply L'Hopital's rule. Limit of x approaching to infinity. Again, on top the derivative, ln is 1 over whatever is inside the bracket times the derivative inside the bracket, which is, the first term is 0. Second term here is going to be minus 2x to the power of minus 2. Okay, the derivative of that, right? And the derivative of 1 over x squared is going to be minus 2x to the minus 3 over, so this is on top, right? This is multiply over 1 over x, which is the derivative minus x to the minus 2. So this is my derivative. Now you can simplify before plug in again. How do you simplify this? So let's look at it like this. So I'm not going to touch this fraction here. 1 plus 2 over x plus 1 over x squared. I want to factorize my minus 2x to the minus 2. Minus 2x to the minus 2 factorize out, and this is multiply here. it becomes 1 plus x to the minus 1. Okay, this is what I factorize. And at the bottom, I have minus x to the minus 2. So I can simplify this minus and this x minus 2 here. Okay, so what does it give me here? What is left on top here? So let's look at this. So I have limit of x approaching to infinity. On top, I have 1 plus, oh, actually it's 2 times 1 plus x to the minus 1 over 1 plus 1 over, well, it's actually 2 over x plus 1 over x squared. Okay, this is basically what's left. And I move this on top of the fraction, and at the bottom is gone, right? So I don't need to write that anymore. So I have a fraction like this now. If I have fraction like this, I have to, let's say this is 1 over x, right? This is basically 1 over x. I replace x by infinity. This is going to be 0. So the answer on top is going to be 2. So if I plug it in, it will be 2 over. Now this is 0, this is 0. And then what I have here is just 1. So my answer is 2. But not quite finished, because I know that my ln of y is equals to 2, right? 2 over 1, which is 2, right? So the limit is gone, but I still have to solve for my y. So y is going to be e to the 2. So this is basically my limit, right? Y is equals to my limit. So if my y is equals to e to the 2, that means my limit is equal to e to the 2. So this is basically my answer here. For more information about L'Hopital's rule and other tricks on L'Hopital's rule, please visit my website goforaplus.com.